Welcome to the Explainer. If you're an IT ops professional, you know the absolute dread of that 3 a.m. pager beep. It usually means something critical just broke, and you're the one who has to fix it right now, sitting in the dark. But what if most of those alerts were, well, kind of just noise? Or better yet, what if you could have caught the issue at 8 p.m. before it ever escalated into a full-blown crisis? Today, we're defeating alert fatigue. We're doing a deep dive into the ultimate tool for Oracle Cloud Infrastructure, or OCI, the monitoring query language. You probably know it as MQL. Okay, let's dive right into this. Here's our no-nonsense roadmap for today's explainer. Number 1, the architecture. 2, mastering MQL and alarms. 3, real-world templates. And 4, best practices. Section 1, the architecture. Let's get a solid understanding of OCI monitoring. Think about it. To build a reliable system, you absolutely need an unshakable foundation. And in OCI, that foundation is the monitoring metric. Simply put, a metric is just a measurement data point related to the health capacity or performance of a resource. Think things like uptime, latency, or memory usage. This is your raw material, coming in as timestamp value pairs attached to specific dimensions. It's the exact data that tells you if you're actually hitting those critical customer service level agreements. But where is all this raw material actually coming from? Well, literally everywhere. OCI generates a massive breadth of data. You've got the compute service natively emitting metrics, custom metrics flowing in via API or SDK, connector hubs, stack monitoring, the database management service, application performance monitoring, and ops insights. The sheer volume of data pouring into the monitoring service is honestly staggering. A complex cloud environment requires a really robust way to parse all of this, because otherwise, you aren't really monitoring. You're just drowning in data points. And this brilliantly illustrates the real problem we face, the intuitive UI versus MQL. Now, the standard OCI user interface is great for basic querying. It's totally fine for looking at standard namespaces or picking default intervals. But to handle that massive data flow we just talked about, you're gonna hit a wall. MQL is absolutely essential because it unlocks complex aggregations, mathematical transformations, and advanced multi-stack filtering. If the UI has a bicycle, MQL is a sports car. If you want to stop those 3 a.m. pages, you've got to upgrade your ride. Section 2, mastering MQL and alarms. Let's look at how evaluations actually work under the hood. Now that we know why we need MQL, let's walk step by step through the alarm evaluation cycle so you know exactly when and how an alert fires. First, metrics aggregate using a 1-minute interval by default. Second, the monitoring service evaluates your alarms once every single minute. Third, if your specific condition is met, qualifying events trigger on those tracked metric streams. And finally, notifications are split and the messages are actually sent out. Understanding this cycle is super vital to mastering your operations. 90 days. I want you to keep this number locked in your head. OCI Alarm History stores the past 90 days of metrics. So why does this matter to your MQL queries? Because it dictates your interval limits. If you're querying a full 90-day range of historical data, the system limits your intervals to somewhere between 1 hour and 1 day. You literally just can't look at 90 days of data in 1-minute increments. All right, Section 3, real-world templates. Time to open the ops playbook. Okay, let's get highly practical. I strongly recommend grabbing a screenshot of these next few templates because you can copy and paste these straight into your own environment. First up, host monitoring thresholds. Check out the syntax we're laying out here. For host CPU utilization, we're setting a warning rule at greater than 80% over the past 5 minutes and a critical rule at greater than 90% over that same 5 minutes. We use the exact same logic for Linux file system utilization. Greater than 80 for warning, greater than 90 for critical. But notice it's evaluated over a 15-minute window. That's to account for temporary file spikes. This specific MQL syntax right here is exactly how you catch a runaway process before the server actually crashes. Next, let's look at your web tier. Now, what's really interesting about this next batch is how specific we can get with application states using MQL. Look at the WebLogic stuck threads. Our warning rule is greater than or equal to 10 stuck threads over the past 5 minutes, and critical is 15. For Apache, we're tracking web request processing time, warning at 1500 milliseconds and critical at 3000 milliseconds. We aren't just checking if the server is powered on. MQL lets us verify if the server is actually doing its job efficiently. And for the DBAs tuning in, we've got you covered. Here are the Oracle database thresholds. Table space utilization warns at 75% and goes critical at 80% over a 10-minute window.
Process limit utilization warns at 90 and goes critical at 95 over 5 minutes. These align perfectly with database management recommended alarms, but they're translated directly into these really elegant MQL mean evaluations.
But wait a second, let's pause and ask a massive million-dollar question. How do we actually prevent false alarms? Honestly, there is nothing worse than the system crying wolf. If your architecture pages you 5 times a night for momentary CPU spikes that literally resolve themselves in 10 seconds, you're going to start ignoring the pager. And that is exactly when a real outage hits.
Which brings us to Section 4, Best Practices. Let's fine-tune for absolute precision.
To tune your alerting, here's your golden rule. Always use group by in the query of an absence alarm. Let me explain why this is absolutely crucial. An absence alarm checks if a metric has disappeared, like if a server unexpectedly drops offline. Well, if OCI introduces a new dimension to a metric in the background, it creates an initially empty metric stream. If you don't use group by, the alarm monitors all those streams, sees the new empty one, and triggers a massive, annoying false alarm. Using group by safely isolates your query. Please burn this rule into your brain.
10 minutes. That is the global internal reset period in OCI. It determines when an alarm stops checking for an absent metric that triggered a firing state in the previous evaluation. Understanding this 10-minute reset helps you figure out why your alarm history might suddenly show a 10-minute gap. It's a globally configured internal behavior, not a weird glitch in your script.
All right, let's rapid-fire some technical pro tips for MQL. First, combine threshold and absence alarms to get really comprehensive multi-stack coverage. Second, use advanced metric namespaces like Oracle App Management or Oracle OCI Database to access richer, deeper data. Third, and this really helps with those false alarms, set your trigger delay to 3 to 5 minutes. Don't alert on second one, wait to see if the system recovers on its own. Next, leverage nesting queries, like calculating the sum of hosts with CPU greater than 80%. And lastly, if your architecture expects to generate more than 60 alarm messages a minute, set streaming as your destination, not notifications, or you're going to hit service limits for sure. I want to leave you with a provocative thought. Does your current alerting strategy actually prevent the 3 a.m. crisis, or does it kind of just report it to you while you're sleeping? So the crucial point is this. OCI's monitoring query language isn't just about reading data. It's about transforming raw metrics into proactive defense. Take these templates, apply these best practices, and audit your own OCI setups. It's time to upgrade your operations playbook. Thanks for joining me on this explainer, and I'll see you next time.